Hi, my name is Maurits Dijkens and I want to show you in this video how easy it is to create mobile applications on the Oracle Internet of Things cloud platform in combination with the mobile cloud service. In this demo we have connected coffee machines that pass their information to the Oracle Internet of Things cloud service, so we have a continuous update of their coffee level, milk level, their power usage, the temperatures, etc. etc. The main reason behind this demo is that if you have service engineers out there in the field who have to service these coffee machines, they can easily see which machines need attention and where they need to go. The modern coffee machine is a connected device that can real-time pass on information about its status. This information can be used for predictive maintenance and to be ahead of problems before the machine is out of order. For this demo I'm going to use a couple of coffee machine emulators because it illustrates very well how the data is passed on to, for example, the IoT cloud service, and how we log the data there and we receive the alerts when the machine needs attention. In the Stream Explorer we can further analyze the data and recognize patterns and do other things there. Further on in the demo we pass information through to the Oracle Mobile Cloud Service to be able to implement a mobile application for service engineers while they are on the road. And for that we use the Mobile Application Accelerator platform, which is a citizen developer tool within Oracle Mobile Cloud Service, so anyone can build easy mobile applications, put them on their phone or their mobile and use them in the field. Oracle Mobile Cloud Service deliver mobile services to mobile application developers for easy connectivity to, for example, Oracle Cloud instances, other internet related services, but also on-premise backend systems like ERP, CRM, etc. Let's take a closer look to these coffee machines and the data that is available in the IoT cloud service. Here I have 3 coffee machines. And as you can see here, all the machines are ready and they are filled with the coffee beans and the milk and sugar level, everything is okay. In these machines I can, for example, choose to create a cup of coffee. And we see the level of coffee going down to 80%. If we choose hot milk, the milk is getting closer. Let's look in the IoT cloud service at the data that is coming in. Here we see the application of the coffee machine data, and we can also see the messages that have been processed in the last 7 days. We see that 3 devices are online, so IoT cloud service has received information from them last couple of minutes, and we can also look at more details of these messages. Let's refresh the list. Here you can see the data that is coming in IoT cloud service for one of the coffee machines. We've just made some coffee and this machine has a coffee level of 80%, a milk level of 80%, the temperature is 91 degrees Celsius. We have the grinder amperage, almost 1 amp. And also the timestamp, the priority. We can see which device it is coming from. And if we look at the device, here we can see that device. We have 80% beans, 80% milk. If we make, for example, cappuccino, we'll see that the beans and milk go to 70%. So I do a refresh here. And we have a message that the coffee and the milk is 70%. Let's look a little bit closer into the model behind this in the IoT cloud service. Here we can see the device model for the coffee machines. In the device model you see some default system attributes like latitude, longitude, the signal strength of the device, But more importantly, in this example, we have custom attributes. And these are the attributes that we defined ourselves for this specific device. And you see the coffee level, milk level, sugar. We have alerts for these, consumption frequency, grinder amperage. In a device model, we can also define actions. And the actions in this case could be to turn on or off the machine remotely, or to reset the machine if we have refilled it with sugar, milk or coffee. There's also one alert defined, low ingredients alert, and this message will be sent to the IoT cloud service. These messages will get into the IoT cloud service when the coffee level or milk level is too low, or if there's something wrong with the machine. Once the device model is created, we can register devices that use this model. Once the device model is created, we can register devices to use this device model. We have the option to register a single device and specify all the details about it, or we can also do a batch registration of multiple devices via a CSV file that has all the data. So if we take a look at the registered devices, we can easily find our coffee machines, and as you can see, they are all activated and they are all online because messages have been received. Let's look at one of the coffee machines, and here we see all the details that are specified with this machine. And here we also see the messages that were received by IoT Cloud Service in the last minutes. So let's take a closer look at the data and how we can process that in IoT Cloud Service. So we go back to our application. We receive alerts when the coffee level or the milk level or something else is too low and we need to do something. And we receive messages whenever something changes in one of the devices. A final thing we need to do is pass over the right information to the mobile cloud service to be able to create mobile apps with these data. If we look at integration, I've set up two integrations here. This is just a test endpoint to send all the messages there, so I can easily check what data and what messages are going to mobile cloud service. But this is our integration to mobile cloud service. We can see that in the last couple of hours we have received messages, and we can also see the connectivity that we have defined. To connect to the mobile cloud service, you have to specify the URL of the mobile cloud service and to authenticate. And as always, you have to specify the Oracle Mobile Backend ID. This is the area in mobile cloud service where you have defined your APIs that need to handle these messages. I have defined two streams. The normal data stream, which contains the basic coffee machine information, including location, customer and operator, and also the alerts, the low ingredients alerts, also with location, customer and operator. If we want to check the kind of messages that are sent to the mobile cloud service, we can see it here, and we have here the regular messages with the coffee level, but we also see here that one of the machines is out of sugar and an alert message is sent to mobile cloud service. Let's generate some extra messages from one of the coffee machines, and we can also generate an alert You can see the messages received by IoT Cloud Service and passed on to Mobile Cloud Service, with the coffee level going down, and finally an alert where we see that we have no sugar, 25% coffee and 35% milk, as we can also see here in the coffee machine. So this was the first part where we saw that the coffee machines were connected to IoT cloud service. There we process the incoming data and we have regular messages and alert messages. We can analyze and process them further there, but in this case we pass them on to the mobile cloud service. Let's take a look at the Oracle Mobile Cloud Service. Here we have the Oracle Mobile Cloud Service. As you might remember, in the integration I had to specify a mobile backend ID, and that is because in Mobile Cloud Service all your interfaces, your APIs, are grouped in a mobile backend, which has the access rights for users or machines to use these APIs. If we look for the coffee machine, so this is the mobile backend that was used by IoT Cloud Service, and we see that in the last 10 minutes we had 10 API calls. Here we also see the mobile backend ID that I used to connect to this specific backend. And if we look into this mobile backend ID, we can see what messages were processed, what API calls were processed, and we have information about maybe errors that happened, but also the put and the post events that came in from IoT Cloud Service. In this mobile backend ID, I defined an API to be used by IoT Cloud Service to pass the messages to Mobile Cloud Service, but this is also the API used later on in our mobile app. Let's take a closer look at this API. The API consists of two parts. The endpoints, these are the API endpoints that can be used by external systems. For example, the IoT Cloud Service uses the Events API, and it passes all the event messages via this API to Mobile Cloud Service. We have here a post, and we can also see here a sample of the message that is handled by this API. This is the kind of message that comes from IoT Cloud Service, and this API should be able to handle that. We can also see the response that is returned back to IoT Cloud Service. In this case it is left empty because IoT Cloud Service is not doing anything with that. I have also defined some APIs to retrieve the data from Mobile Cloud Service. You see that with the blue icon here for the get methods. I can get information about all the machines, information about a specific machine. I can get all the alerts or about a specific alert. If we look at the machine data that can be retrieved, we see here a nicely formatted message with only the data that we might need in our mobile app. So these interfaces are defined with the mobile app in mind, and it only presents the information needed. So the messages are very clean and lean to send over. But this is just the interface definition. Definitions are very easy to create. You can specify sample, content or payload that is sent or received by this API, and it makes it possible to easily test it and to use it from IoT or a mobile app or whatever. But we don't have an implementation yet that defines how we should process the message. If we look at the implementations, I've created the implementation here. I can download it. Here we see the implementation of these APIs. The implementations are implemented in Node.js, which is JavaScript on the server, and you see all the code here for the post API. This is the method that handles the incoming data from IoT Cloud Service, And this might look like a lot of code, but 99% of what you see here is already generated by Mobile Cloud Service. I just had to specify that I want to store the content in a small database in Mobile Cloud Service with the table names, and when we get machine information like this one, I have to specify that I want to retrieve that information from a database table. That's basically all that is happening here in this implementation. Okay, so we've seen how to define an API in Mobile Cloud Service. Let's now look at the implementation of a small mobile app created with Mobile Application Accelerator. Mobile Application Accelerator is an environment for, as we call it, the citizen developer. So if you want to develop an app and you don't have any knowledge about programming language and parameters and variables and conditions and these kind of things, then Max is the environment for you, because we've already put all the difficult stuff in the API implementation in Mobile Cloud Service, and in Max we are just presented with data objects that we can use in our screens and specify how we want the screens to look. So let's take a closer look at Mobile Application Accelerator. Mobile Application Accelerator is a part of Oracle Mobile Cloud Service, and we've also added some nice descriptions with it and some easy to use formats. So in this environment you don't need to know anything technical. So let's create our coffee app, and the basic look and feel of my app, I can choose to have tabs on the top and some content below that. Let's say this simple app just has one screen, so it's coffee machines, and we have one tab for the machine information, one tab for alerts, and maybe some graphs to show the status. Okay, on the first tab, the machines tab, I want to have a list. I choose this one. And now Mobile Application Accelerator is ready to create our app. So let's add some data to the app now. And on our first tab, the Machines tab, I can specify the kind of list layout I want. And also here we present the user with predefined styles, so they don't have to worry about how to create these styles. And now I have to specify where to get the data from. And we can see here the APIs in Mobile Cloud Service that we have made available for the Mobile Application Accelerator user. And here we also see our MD Coffee API. So I select that one. Max is automatically detecting which business objects are used and available in this API. And for our first tab we use the machines object. And now we can see all the fields that are in this object. We have taken care in Mobile Cloud Service that these field names are user-friendly, and we don't use all the technical terms behind it that came from IoT Cloud Service, but we just use something like customer and milk and temperature, etc. And here we see our list view. We can also do a live data view, but it's still empty. And we can specify which fields of our business objects should be mapped to the fields in our list. So let's first put a graphic in front of every line, and we use the priority of that. Max automatically detects that the priority field in the business object can have 4 values. It can be low, medium, high or highest. And here I can specify which icons to show in the list. So for low I use this green one. For medium, the orange one. For high, the red one. And I think this one is even more red. There we go. In the live view we can immediately see the update of how our list will look. In the title field we want to show the customer And now we can see that the customer is Oracle or Google. And in this same field we also want to specify the ID of the coffee machine. So we put both fields in this title field, and now we have Oracle this machine and we have Google this machine on the same line. In the subtitle field we put the time of the event, and in value 1 we can show the coffee level and the milk level, and in value 2 the operator responsible for maintaining this machine. And now we can see what our screen in our app will look like, and I think this is fine, so I'll just finish it. For the alert tab we do kind of the same. Also here I want to show a list and I want to add data to it. The list format is fine. Now I choose the alerts. Use the same priority again with the same icons. In the title we want to have the customer and the ID. In the subtitle field the time. Value 1 is coffee, milk, sugar, and we have the operator in value 2. This is what it looks like. Looks fine to me. Finish. On the third tab we are going to put some graphs, and I use a dashboard component to be able to use multiple graphs here. And on the first one I want to have a chart, and let's look at the properties to make it a little bit more nice. Horizontal bars, and I don't want a legend and also not the title. And in this tile I want it to be wider, and as a title we put in coffee percentage, and we want a second tile also that same size, and that is the milk percentage, and it's also a bar chart. Let's look at the properties again. No legend, no title. Okay. So let's add some data to that. We have machine information, and I want to have coffee information on the y-axis and ID for the colors and the access. Finish. Let's do the other one. Data, also machine information, and now we want to have milk in that graph. There we go. A last thing that we can do is add a detail screen for the machine, so we can see all the detail information coming from IoT Cloud Service. And for this screen I just want a simple screen. Call it details, and we want to have a form with all the data fields on it. Finish. Go to the detail screen, add some data to it, also machine information, and for the sake of speed and simplicity I just take all the fields, and I can also sort them here or do other stuff, but for now I leave it like that. And it should be connected to the parent screen based on the machine ID, but it is automatically filled in already. The last thing I want to add is a refresh option on the page. And let's give it the name refresh. And if we tap on refresh, we want to refresh all the data. Let's now test our app. Here we can see the machine information. If we just make another coffee, and we do a refresh here, we see that the coffee level is now 5%. Let's take the second coffee machine and make some coffee. We now have this second machine on 25% beans and 25% milk. Let's refresh. That's what we see here. If we look at the details, we get all the information about this machine. And also in the alerts, we should have received an alert for this machine, 25-25, and we also have graphs. We can see the coffee and the milk level of the machines. Let's change the third machine and use a lot of milk there. And now we can see that the milk level on the Utrecht machine is on 0. Application looks nice, so we can now publish it to our phone. Publish, and we want to download it to our device. And on my device I have the Max app installed, and I can start it. And with the plus sign in the lower right corner we can add a new app, and we scan the QR code. And there we have our app. I have to log on. And from now on I have this app on my mobile phone. I can take it anywhere and have an immediate insight on the machine status and the alerts and the graphs. And as you see, it's all working real time. Let's reset this machine. And we do a refresh here. And we see that this machine here is now updated to 100%. Let's make some coffee. We do a refresh in the app. We see it's now 60%. Make some milk. Refresh. 60-60. And the graph also shows that we have 60% coffee and 60% milk. So this is just a very simple example of how you can easily create mobile apps for on the go. People without any development experience can create these apps based on the business objects that are provided from Mobile Cloud Service. Thank you for watching this video.